So today we're going to be looking at variance of probability distributions. And in particular, variance is a measure of spread in the same way that range or interquartile range or standard deviation. In fact, standard deviation is going to be talked about in a bit. But variance is a way of calculating the variance, or some variation, the spread in it. Now, you'll notice it looks quite similar to the previous function we've dealt with, which was the probability times the I, except this time we're comparing each xi to the mu. And if you remember from before, mu is just the expected value, so that's e of x, right? Which we sometimes call the mean instead. So what is this function really doing? Well, this is finding the difference between the value and the mean, okay? Now, something we often do is the problem with whenever we do subtraction is that sometimes we get a positive answer, sometimes we get a negative. Sometimes we don't care whether it was positive or negative. What's the solution? We square it. So something that we can do is we can square that, and that gives us a foothold. So once we squared it, it's going to be positive no matter what, and then we just multiply it by the probability, add them all up. Now, a really common symbol we use to actually give this var x a name, similar to how we give mu this e to the x, is we go rho, we call it rho squared, okay? Sorry, not rho, sigma. So this is a little sigma. Alrighty, so sigma squared is sometimes what it's called. Now, for a bunch of reasons, there are many ways that we can actually represent this piece of information. This is one particular formula. This is the one that's on the formula sheet. However, there are many other ways of calculating this. So some alternative formulas for var x include, we can calculate var x as being the expected value of x minus, not the sum, the expected value of x minus mu squared. We can also work it out by doing the sum of x minus mu squared pi, which is just an alternative writing of our formula, putting the pi second. And probably one of the more useful ones that comes up a fair bit is the expected value of x squared minus the expected value of x squared. Okay, so these are three different formulas. They might come up from time to time. This is probably the most useful one, because if you already know the expected value, you just need to work out the expected value of x squared as well. Alrighty, so let's have a crack at one ourselves. So to work out the expected value, part A, we've done this before. E of x is just going to be equal to 1 times 0.2 plus 2 times 0.15. And you're going to add up all of these values. And when we add them all up, we get 12.65. Alrighty, so now that we have, oh sorry, not right, 3.15. Big error there. Alrighty, so now that we've got that, now we can calculate the variance. So like I said before, there's a few ways we can calculate this. I'm going to be using this formula, so var of x is equal to e of x squared minus e of x squared. Alrighty, so we already know what e of x is, we've just worked that out up here. What we need to work out is e of x squared. So first of all, let's do up our distribution table. Alrighty, now I'm going to be using, this is just my original table. What I want to do is now I want to square it. So I want to square all of this, so I work out what each of my x squareds are. It's going to be 1, 4, 9, 16, 25, 36. And now I can work out the expected value of x squared by just multiplying each of these. So 1 times 0.2, 4 times 0.15, all the way down. And once I've worked out all of these, it adds up to 9 12.65. Alrighty, so I've now worked out the expected value of x squared, and I've also worked out the expected value of x, and now I just need to use the formula. So let's go through and do it. So the var of x is equal to expected value of x squared minus the expected value of x squared, which is going to be 12.65 minus 3.15 squared, which equals 2.7275. Alrighty, and just a reminder, this is equal to sigma squared. That's what our variance is equal to. Alrighty, so that's how you can calculate the variance, and probably the simplest formula to use. However, the only downside is that it is not on the formula sheet. Alrighty, I'll see you in the next one. We're going to look at the standard deviation.